Okay, so today we're going to be going through our word equations, which is just similar to our chemical reactions, but with the now addition of the fact that it's not written as an equation, it's written as a sentence. And we will need to convert that sentence from that format into our chemical equation format. So, our goal, big bold letters here, write the chemical reaction equation and balance it. So, I have an example at the bottom here, and this is the one we're going to use. Barium oxide solid is placed into a container of liquid dihydrogen monoxide and reacts to produce aqueous barium hydroxide. So we're going to take that sentence and convert it into a chemical equation in this format down here. So we have our format set up for coefficient, compound, state, coefficient, compound, state, coefficient, compound, state. So that's what we're going to be using. Now, I have a set of steps here that we can follow in order to get this set up correctly. Now, with these steps, I do want to say that it's not super cut and dry. Some people can kind of go through these steps in more of like a flow versus trying to do each part one at a time. I'm going to go through each step one at a time because I feel like that'll make things most clear as to what we're doing. But these aren't hard rules you have to follow. Um, First thing we want to do when we read this example problem, we want to identify all the parts of our chemical reaction. So for me, first thing that means, what are the compounds and elements? What are the things that are actually reacting in this problem? So here I have first barium oxide solid. Barium oxide. That is my first compound. I want to highlight that because I'm trying to identify that that's one of my compounds that I have. Barium oxide solid is placed into a container of liquid dihydrogen monoxide. There's another compound, dihydrogen monoxide, very helpful to have, and reacts to produce aqueous barium hydroxide. So those are my three compounds: barium oxide, liquid dihydrogen monoxide, and barium hydroxide. There's no other compounds or elements listed here, so now I can move on to my next step, which is identifying the states. States being like the states of matter that we might have. So we could have just solid, which may also be written as precipitate. As we talked about, precipitate is a sign of a chemical reaction. It's just saying that there's a solid coming out of the solution. So when you mix two liquids together, you make a solid. So that's one of the things we can look for. So when we see that word solid or the word precipitate, that's our state of matter. It's just that S. If I look through my example here, barium oxide solid, there's that word solid. So I know the state of matter for this substance is solid. So I'm going to use a little s abbreviation to represent that. I don't see the word solid or the word precipitate anywhere else, so now I can move into another state of matter. Next state of matter being just liquid. And liquid is pretty straightforward. You'll only really see it as liquid ever, and we use a little L to abbreviate that. So when we look through, barium oxide solid is placed into a container of liquid dihydrogen monoxide. There's our word liquid. So that tells us the state of matter for this substance is liquid. And I'm going to use a little L with that substance. Then I can have a gas substance. I can have gases, also known as bubbles, when we see those chemical reactions occurring. So if you see something described as having bubbles made, that's a sign of a chemical reaction as well, which we will abbreviate as a G. I don't see gas or bubbles anywhere in our sentence, so I think we're good on that front, which leaves our last state of matter as aqueous. You may also see written as solution at some point. And that just means that whatever you have is dissolved in water. So think like salt and water or making Kool-Aid, anything like that. It's dissolved in water. It's called aqueous. Now, I do see that word aqueous here, meaning that our last substance, barium hydroxide, is in the aqueous state of matter. So now what we've just done is we've looked at our different compounds that we identified, barium oxide, dihydrogen monoxide, and barium hydroxide, and identified their states of matter: solid, liquid, and aqueous. That tells us what they'll look like in the actual reaction. Next, we can look for, do we have reactants or do we have products? And this is important because as we set up our chemical reaction, it's important to know what is on which side of the arrow. Is this element a reactant or is it a product? Is it going to be on the left side or the right side? And just because it's written, right to left, and that we read our equations right to left, does not always mean that the reactants are written first. Sometimes it'll say that a substance is made from mixing A and B. And you really want to make sure you're paying attention to what is actually being said here. So when we look at reactants and products, we're looking for some key words. For reactants, things that we're looking for add, we're looking for mix, we're looking for react, just react itself, placed in, things like that. That tells us that something is a reactant. So here we have in our sentence, barium oxide solid is placed into a container of liquid dihydrogen monoxide and reacts. So this word here, the fact that it reacts, tells us that the things up to this point are reactants. Specifically, barium oxide is a reactant, and it's placed into, meaning that these things are together, placed into a container of liquid dihydrogen monoxide. So this must also be a reactant. Two reactants together. For products, that'll be anything after these words, typically. Things like produce or produced, makes or make, yields or yield, form, or even if you have like a decomposition reaction, breaks down. All of those are good signs that whatever you have next is a product. It is something that's being made. So as an example here, we have reacts to produce. There's our word, produce, meaning that anything after this point is our products. So here we have a product, aqueous barium hydroxide. You'll notice that I started putting plus signs and arrows in, and that's because it helps me to keep track of what the equation is going to look like. So just to show you, here's what we kind of have so far for our equation. Now, note we don't have any formulas yet. We'll do that part next. But our equation so far just kind of looks like this. We have barium oxide in the solid state of matter is being placed into our container that contains liquid dihydrogen monoxide. So we're making this dihydrogen monoxide here, and it's in the liquid state. And we're mixing these things together to produce our aqueous barium hydroxide. So without any subscripts, coefficients, none of those identifying numbers here, this is what our formula looks like. If I were to try to just give this formula to somebody, it wouldn't be very helpful. It doesn't tell me how many of anything I have. It doesn't really tell me anything about what I need. It just tells me what these things are. So our next step is going to be to actually change these from the names to the formulas, convert any names to formulas. And this is the part where we're thinking back on what we've done in the past. So if we have an ionic compound, ionic compounds means there are no prefixes in the name. Ionic compounds, those mean charges. We're going to be balancing charges if you see those ionic formulas. Ionic compounds mean we need charges. So when I see barium oxide here, see how there's no prefixes in this name? There's no dis, no tris, no none of that. This is an ionic compound. Meaning we need the charges for both barium and oxide. So we'll do that in a minute. We'll get to that one. If, however, we do have those prefixes, then we're going to use them. So covalent compounds, we're going to use the prefixes. So as an example, dihydrogen monoxide, we have the prefixes di and mono, right? Those are prefixes we can use for our covalent compound. This compound is covalent. This third option here, barium hydroxide, we can see that there's no prefixes. So this compound must also be ionic. So now we have to actually look up, well, what are the charges of this element? This is where you're going to need to bring back your periodic table. Specifically, I would have one that has your list of polyatomic ions and our prefixes list. That way we can look up and see what these charges are and what the prefixes mean without having to try to have things memorized from the past. So I'm going to start here with just looking up barium first. Just going to look up barium first. Now, barium is down here. It's in our second column, meaning that barium has a +2 charge. So barium, Ba, is +2. Oxide means oxygen, right? So we're looking for oxygen. Oxygen over here has a charge of -2. If we're in group 16, that's a -2 charge. Now remember, our goal for any time that we use polyatomic, or anytime that we have ionic compounds, our goal is to always get that charge to be 0. So we have barium with a +2, oxygen with a -2, +2 -2 ends up equaling out to be 0. If I've done that math right, +2 -2, the total charge is already 0. So our formula is just the combination of those two elements. Ba and O. So this is my formula for barium oxide, BaO. And I'm going to put that right here in my spot for my first compound. Since I've listed it first already, doesn't really matter. I'm going to put it first. BaO. And if we remember, we've already identified that that substance is a solid, so I'm just going to go ahead and put that solid marker down there. This for every compound we have in our chemical equation. So next up we have dihydrogen monoxide. That is a covalent compound. So we're not really looking at the elements per se, we're looking at the prefixes. So I'm going to look here for what my prefixes are. I have the prefix di. Prefix di means 2, so I'm going to have 2 of whatever my first element is. Specifically, that'll be hydrogen. And then I have the prefix mono, which means 1, so I have 1 of the oxygen. So for dihydrogen monoxide, my formula would be H2O. 1H or 1O, 2 H's to make my compound. And this again is in that liquid state, so I'm going to use a little L here to represent liquid. And then finally, we have barium hydroxide, which is another ionic compound. So if you want to go ahead and practice balancing this one, now would be the time. I'm going to walk through this. Luckily, we've already identified what the charge on barium is. It's +2. The nice thing about doing this is you don't have to look up everything every single time. Once you've found the charge for one element, you're going to use it again. So we've used barium already. Hydroxide is the hard one. Hydroxide is a polyatomic ion. It's one of our only polyatomic ions that has the ending IDE, but it's a combination of hydrogen and oxygen. So that's how we know it's polyatomic. And the charge on hydroxide is -1. So we have OH with a -1 charge. Now remember, our goal is to get our charge to equal 0. Right now our charge equals 1. So in order to get the charge to equal 0, we need to have another OH included. That will change our charge, so it's no longer equal to 1, it's equal to 0. So the formula for this compound is BaOH, and the OH is in parentheses because there are 2 of them. So this right here is my second compound, or my third compound, second ionic compound, BaOH2. And I place that in my final spot as it is one of my products. So my final product here, BaOH2. And the state is aqueous, so I'm going to put AQ in that little spot here. So all I've done is taken what we've done before, which is write formulas from element names, and we've just placed them into that same spot. This format is the same as what we had up here. The only difference is we've gone from names to compound formulas. And now our last step is balancing. And at this point, we've all gone professional in balancing. So I'm just going to kind of run through this balancing pretty quickly here. We've got barium on this side, barium on this side. We have hydrogen on this side, hydrogen on this side. And then we have oxygen. We have oxygen here, and oxygen here, and oxygen here. And if we look and try to add these up, for barium, I have 1 on my reactant side, 1 on my product side. For hydrogen, I have 2 on my product side because of the 2 here. I have 2 on my reactant side because of the 2 there. And then for oxygen, I have 2 on my product side and 1 plus 1 on my reactant side here. 1 from this oxygen, 1 from this compound. So that ends up balancing out already. You can kind of see here. So our coefficients don't actually really need to be anything other than what they already are. So our coefficients are just 1, 1, 1. These do take quite a bit of work, so do not be scared by how much work these do take. I am aware. There's one more example from on the back that I'd like you guys to try. Copper wire is placed into an aqueous solution of silver nitrate. A new precipitate of silver is formed as the wire dissolves to make copper 2 nitrate. I will point out, just because I'm not sure it's very clear, that this copper 2 nitrate is aqueous. I just don't think that's very clear. But go ahead and give this one some practice. See if you can put it into the correct format. I have the format laid out for you. So all you're going to try to do is, number 1, identify your parts of your chemical reaction, compounds, states, reactants, and products. Convert any names to formulas, and then balance. That example one more time.